In this video, we will learn how to evaluate expressions involving the inverse trigonometric functions. So, expressions involving trigonometric functions and their inverses arise very frequently in calculus. So it's important to have the skills necessary to evaluate such expressions as those. We've looked at some things like this before, so hopefully getting right into examples will help you understand how to apply these concepts. Write sine of cosine inverse of x plus tangent inverse of y as an algebraic expression in x and y. Of course, in this case, x is between -1 and 1 because that would be the set of inputs for sine or for cosine inverse, and y is any real number since that's the set of inputs for tangent. So now, let's do this. Let's say, all right, well, since cosine inverse of x gives us an angle, let's call that theta. And since tangent inverse of y also gives us an angle, let's call that phi. Phi is just a Greek lowercase letter. So now let's draw some triangles. Since these pieces of information tell us that cosine of theta equals x, and tangent of phi equals y. With these pieces of information, we can compose some triangles. So let me pick a different color. So for cosine theta, since we just have x, we'll call this angle theta and this a right angle. We take the adjacent side over the hypotenuse. And in this case, the hypotenuse is just 1, since we have just x here. So we have x over 1, which then, if we use the Pythagorean theorem, gives us square root of 1 minus x squared for our remaining side. And similarly, maybe I'll draw a slightly different triangle, like this, with a right angle, and we'll call this phi. So if tangent of phi equals y, what that's saying is we have y over 1, which this is, the opposite over the adjacent side, so we have y and 1. And then we just use, again, Pythagorean's theorem, so we have the square root of 1 plus y squared for the hypotenuse. Now, since we have this angle and this angle, we could write sine as sine of theta plus phi, and then we can just use our addition formula for sine. So this is sine theta cosine phi plus cosine theta sine phi. Okay, and last but not least, we just plug in some numbers. So sine theta, we know that in this case is, in our green triangle, the opposite side over the hypotenuse. So that's root 1 minus x squared over 1. Cosine of phi is the adjacent over the hypotenuse. So that's times 1 over the square root of 1 plus y squared. Then we add cosine of theta, which, again, we just said that one was x, and sine of phi. And sine of phi is the opposite over the hypotenuse, which gives us y over the square root of 1 plus y squared. Now, we could just simplify this a little bit since we've got a common factor of 1 over the square root of 1 plus y squared. So we have 1 over the square root of 1 plus y squared, and square root of 1 minus x squared plus x. And this is our final answer. So essentially what we do is we remember that cosine inverse and tangent inverse both give us angles. And using that information, we create some triangles. And then use the sine addition formula of those two angles to get us an output in real numbers. Okay, next one. If we wanted to evaluate sine of theta plus phi, where sine of theta equals 12/13 in quadrant 2 for theta in quadrant 2, and tangent of phi equals 3/4 in quadrant 3 for phi in quadrant 3. Okay, so for these, we'll take a similar approach. We'll first draw some triangles. So let's start with theta. So if we have theta is in quadrant 2, and we have 12/13, that says that the y is rather large and the hypotenuse is rather large, so maybe we look something like something like this. So we have the opposite side, which is 12, over the hypotenuse, which is 13, and this angle is our theta. So then we just use the Pythagorean theorem to find the adjacent side for that angle. So if we have x squared plus y squared equals r squared, we should have x squared 12 squared equals 13 squared, which then we do the calculation, we get x squared equals 25, so x equals 5, but we're in the second quadrant, so x needs to be -5. Now similarly, for phi in quadrant 3, we'll draw our coordinate plane. So phi is probably going to look something like this. And that is our angle phi. Remember, we start on the positive side of the x-axis, and then we rotate around, and that gives us phi. So in this triangle, we know that tangent of phi is 3/4. That's opposite over adjacent, but since we're in quadrant 3, we need to remember that those are both negative. So the opposite side would be -3, the adjacent side would be -4, and then that's just a 3, 4, 5 triangle, so we can call that 5 for the hypotenuse. Now, once more, sine of theta plus phi equals sine theta cosine phi plus cosine theta sine phi. And now we can just substitute. So what's sine of theta? Sine of theta first is 12/13. Cosine of phi, that'll be the adjacent over the hypotenuse. That's going to be -4/5. And then we add a cosine of theta, -5/13. And then a sine of phi, which will be -3/5. And if you calculate that, that's -33/65. The idea simply is that we use our right triangles and our knowledge of the trigonometric ratios to create some situations that satisfy the given information. Then we just use our addition and subtraction formulas of sine, cosine, whatever particular thing we're given to evaluate the trigonometric ratios of those angles in the triangles.